Yo, what's up? This is your boy Timmy and welcome to my presentation. Hope you guys enjoy the moment and get the great lesson from me because I really put many effort and my blood, sweat and tear into these presentations. Hope you guys can enjoy it. Thank you so much. Hello. So I will right now I will explain about the dog product. Okay, so let's get jump right into it. We have like a beta 8 time with beta B's will equal the magnitude of 8 time with the magnitude of B time the cosine of deltas. So let's just visualize to get a more like a clearer picture. Okay, so beta A is in here, beta B is in here, cosine, sorry, the deltas in here. In here we can also it is also can be written down at the magnitudes of beta A's time with the cosine of deltas and time it with the magnitudes of beta B. Okay, so right now I want to find the values of the magnitudes 8 time with the cosine of the deltas. So let's just from 8 are perpendicular with the vector B in here. Okay, so what is the cosine of delta? So cosine of deltas will equal the adjacent over the hypotenuse. Okay, so cosine deltas will equal adjacent of it is, or we can say it is the projections of the vector A, or we can written it down delta A, the projections of delta A over magnitudes of vector 8. So the magnitudes of the projections of vector 8 will equal cosine deltas time with the magnitudes of vector 8. Okay, so we can see in here the magnitudes of the projections of the vector A will equal cosine of the deltas time with the magnitudes of the vector 8, which is also in here in the first formulas in here. So this can also be written at the projections of the vector 8 time with the magnitudes of the vector b. Okay, so right now I will explain the definitions of cross product. Okay, so cross product is written as vector A's cross vector B will equal the magnitudes of vector A, magnitudes of vector B, and time with the sides. The side are of the the angles between those two vectors. But with the cross product, it just happened in the 3 dimensions, so it also has the direction, and this direction is written as the vector end. So just visualize to make is more making sense. Okay, so I have a vector A's in here, vector B's in here, and the angle. Okay, let's just assuming that vector A's equal 5, the angle equal 30°, or you can say it pi over 6, and the vector B is 10. So according to the formula, we will have vector A cross vector B will equal 5 times 10 multiplied by sin 30 degrees times with the vector n. It will equal 5 times 10 times 1.5 times delta n. It equals 25 n. But it hasn't done yet. One more thing we have to do is, this is like the 3 dimension, so there's still one more lines in here. But we have to find the directions of the vector n. So there is a method, the method that you can use called the right hand. Okay, so the right hand method. Okay, so just put your finger according to the vector 8, and your middle finger according to the vector B. And as you can see, my thumbnail is pointing into the board, so that can say that the vector n will go inside the board. Yeah, that's it. Thank you. First, sorry about the quality, but this is rush hour. so I have to do it like really fast. So the continuous grabbed, I can draw for you is that you can imagine that there is a graph in here, and maybe it's like up down like this, but just if they don't break away, or they don't have space, or just they just need to like join together, then it's gotta be continuous graph. And these next three graphs are gonna be this continuous at some point. Okay, so there is a graph. Okay, and yeah, it's look really noble, but somehow at x equal 1 there's a hole in here, and sorry, but I have to say this is discontinuous at x equal 1. And down here I have another example. There is a function, and the graph is like this, and sorry, just have to in the same value of x, sorry, here like this, x equal 1, and you can see between those two lines there is a space, so this one is also considered as discontinuous at x equal 1. Okay, move to the last but not least conditions that you can recognize this is a discontinuous graph. Okay, and at x at 1 there is a vertical asymptote, as you can see, like this. So this is also considered at discontinuous at x equal 1, and this line called verticals asymptotes. Thank you for listening. Hello. So right now I will explain about the average rate of change of a function. So if I have a functions like this, how can I find the slope of the functions? First of all, I have to put 2 points in the functions, and that I can make a line through the graph. Not that the line can really describe how the function is changing. Okay, so if the line is really stiff, then your functions is develops, rise really quickly. And I have just finished explaining to you guys the average rate of change. So right now I will jump right into the instantaneous rate of change of functions. Okay, so if I have functions like this, okay, so if I want to see how this function changes over time, instead of using 2 points, right now I just need 1 point to describe it. So instantaneous rate of change used to scale the rate of birth of the word or the velocities of a rocket launch after a few minutes. Okay, so let's guess the idea. So how can you describe the chance of functions with just 1 point? Usually we need 2 points to have like the final point and the initial point, so that we can use the average rate of change, like the final point minus the first point, like this. But right now we cannot use it anymore, because remember, all functions right now we just describe it with just a single point. So okay, so if we think about it like clearly, it's just like the average rate of change, but we scale it with a smarter way. Okay, so the average rate of change, okay, we just draw it like this, and then we approach this point closer and closer to this point until we can get those points collinear. This is, and that's when they closer and possibly settle on. And then they get closer and possibly settle on some specific value. Right now we will get the idea of limiting.